Hello students, welcome back to our channel Diksha Karnataka. So your COMEDK 2024 examination is approaching. So we have started a series where we are discussing the top 30 questions of all the high weightage chapters from chemistry, right? So in today's video, we'll be discussing the top 30 questions from one of the most high weightage topic from inorganic chemistry, that is coordination chemistry, okay? So you can expect 3 to 5 questions from this chapter, okay? Inorganic chemistry, most of the portions are deleted. So that is why coordination chemistry becomes a very important chapter and an easy and scoring topic also. So let us see these questions. You have to just start doing it with me. So if you have any doubt in any question, you can comment down. And just if you are able to do these questions, because most of the questions are from previous year papers, so you can assure yourself that this chapter is ready, or you can also know where you have to improve, okay? So that's all. Now let us start with the first question here. So the first question is from your isomers. The two isomers of a compound are given Ma3B3 type, okay? So what are their, like, what type of isomers are they classified as, okay? So if you know this, when three ligands are on the same phase, we call it facial isomer, right? So if you see these three ligands, okay, these three ligands are on the one phase of a octahedron, right? So this is your facial isomer and this one is your meridian isomer. So the correct answer for this question will be option number A, okay? Next question, the magnitude of magnetic moment of the NiCl4 2- is. So first of all, let us calculate the oxidation state of nickel. So that is, if you see x minus 4 is equal to minus 2, so x is equal to plus 2. Now nickel electronic configuration you must have remembered by now. So what is the 3d8 4s2? So that means nickel 2 plus is 3d8. So if I draw 3d8, what I'll get? So we have 1, 2, 3, 4, 5, 6, 7 and 8. So number of unpaired electrons is 2. So the magnetic moment will be 2.8 something, right? So the correct answer for this question is option number A. Next, the coordination number and oxidation number of X in the following compound is. So coordination number, you can see 5 plus 1, 6. So here also you should be very careful what is asked in the first. First is asked coordination number, so answer is 6. So we can eliminate these two options, right? Now the oxidation state. So if you want to calculate here X, let the oxidation state of X be X. For sulfur it is minus 2, and then if this is minus 1, so minus 1 is equal to 0. So X is equal to plus 3. So 6 and 3, that is the correct answer is option number A, okay? Next, the formula of the complex potassium trichloridoethylene platinate 2. Okay, so first is potassium should be outside. So in all the options potassium is outside. We cannot eliminate any option on that basis. Trichlorido, so there should be 3 chlorine. So all the options are having 3 chlorine. Then we have ethylene, right? So in ethylene, according to the question, there is only one ethylene molecule, right? So you see here there are 3 ethylene molecule. There is here also 3 ethylene molecule. We can eliminate these two options. Now these two are remaining. Now we have to eliminate on the basis of the oxidation state. So if you see the oxidation state of platinum here, K is plus 1, right? Then platinum we have to calculate, let it be X, and chlorine is minus 3, and C2H4 doesn't have any oxidation state, so is equal to 0. So we will get X is equal to plus 2, right? So platinum is in plus 2 oxidation state. Here also platinum is given in plus 2 oxidation state. So the correct answer for this question should be option number A, okay? Now let us calculate this one and see. For potassium it will be 4 because 4 potassium are there. Platinum is X, chlorine is minus 3 equal to 0. So we will get minus 1, right? So that is not the correct answer. Therefore option A will be the correct answer. Next, the spin-only magnetic moment value in Bohr magneton of CrCO6, okay? So if you see CO6, it has 0, the charge is 0 on chromium, right? So if charge is 0, so now what is the electronic configuration of chromium? 3d5 4s1, right? So we can, 3d5 4s1. So if I draw like this, we'll get 1, 2, 3, 4 and 5 and 4s1, right? Now you can see CO is a very strong field ligand. So what will happen in the excited state? In the excited state, there will be pairing of electrons, right? So in this 3d orbital, we will have 1, 2, 3, 4 and 5, 6, right? So we can get D2sp3 hybridization, but there is no unpaired electron here. N is equal to 0, so magnetic moment will be 0. Correct answer for this question will be option number A. Okay, next, if delta O is less than P, the correct electronic configuration for D4 system will be. If delta O is less than P means it is, you can see that splitting will be very less, okay? So we have this splitting, okay? How I can know that it is octahedral? Because it is asking T2, G, EG, all the options are in G, that is octahedral splitting, right? So now this delta O is very small. So we have 4 electrons means 1, 2 and 3. Now because of this small energy gap, the 4th electron can easily go to the excited state or the higher energy level. So the configuration will be T2G3 EG1, okay? So the correct answer for this question will be option number B. Next, choose the correct options for NiCO4, NiCN4 2- and LiCl4 2-. Okay, so if you see all the options are with regarding to the magnetism property, okay? Now if you see Ni, oxidation state of nickel is 0, so that means it has 3d8 and 4s2 configuration. Now if I draw this one, we will have 3d and 4s, 1, 2, 3, 4, 5, 6, 7 and 8 and 4s2. Now what happens, you can see for coordination number 4, the 2 hybridizations possible are dsp2 and sp3. So what happens, because of this is a strong field ligand, the pairing of electrons will take place and we will get the configuration like this now. So the configuration now will be, right? So now you can see there is no unpaired electrons here. Even though it is a strong field ligand, the hybridization here will be sp3, okay? If sp3, then it is tetrahedral. Now NiCN4, we know it is a strong field ligand. Here the dsp2 hybridization will be there, so it will be square planar. Next is NiCl4 2-. So this is also a weak field ligand. Weak field ligand means again we will have this one will have your sp3 hybridization, and that is tetrahedral. So what I am getting, NiCO4 and NiCl4 2- will have tetrahedral, NiCN4 2- will have square planar. So if you see the third option, we have, let us see the first one, NiCO4 and NiCl4 are diamagnetic, okay? So we forgot about this one. So diamagnetic, if you check, here there is no unpaired electrons, right? In NiCO4, there is no unpaired electron, so it is diamagnetic. Now if you check for NiCN4, okay, so NiCN4 is also +2 oxidation state, 3d8. So there also there is no unpaired electron. So NiCN4 is a strong field ligand, pairing of electrons will take place. So this is also diamagnetic. And if you see NiCl4, right, so here we have 2 unpaired electrons, okay, so this is paramagnetic. So what I can say, NiCO4 and NiCl4, this is wrong because this one is paramagnetic. Next one, this one and this one are diamagnetic. Again, this is paramagnetic, so this statement is wrong. These two are diamagnetic and this is paramagnetic. This statement is correct. So option number C is the correct answer. Okay. Next, in photography, hypo is used as, so it is a complexing agent. Okay, hypo, the thiosulfate solutions are used as a complexing agent to remove the excess of silver. Okay. Next, which of the following is not an organometallic compound? Okay, so if you know this salt, it is a reagent where we have a ethylene group. Okay, ethylene group is present in this one. That is why it is an organometallic compound. In Grignard reagent, we have RMgX. Right, this R part is there, so it is also a organometallic compound. But in cisplatin, we have PT, NH3, and Cl2. Right, there is no organic compound, there is no carbon compound. So that is why this is not a organometallic compound. Option C is the correct answer. Next, CuSO4 with KCN solution forms. So it forms CuCN4K3. The correct answer for this question is option number A. Okay, next, the solution of the complex CuNH3(4) in water will. So if you see how will it dissociate, so this question is from your Werner's theory. So it will dissociate like this. CuNH3(4) is one ion, okay, and SO4 2- is separate ion. So this solution can give a test for sulfate ions because it can produce sulfate ions. So the correct answer for this question is option number C. Next, the formula of dichlorobisuria copper 2 is, okay, so let us see first. We have dichloro, right? So there should be 2 chlorine. So this option is not having 2 chlorine inside the bracket, we can eliminate it. Here we have 2 chlorine, but there is outside the complex, this urea is there, so we can eliminate this one also. Here also chlorine is outside the complex, we can eliminate it. If you check this one, here there is dichloro, and here we are having bisuria. So the correct answer for this question will be option number D. Next, the ligand called pi acid is, so CO ligand is a pi acceptor ligand, we know. It can donate electrons to the metal and also it can accept electrons from the metal. So that is why it is a pi acid ligand. Correct answer is option number A. So here is DsP2 hybridization is found in which of the compounds, right? So NiCl4 we already know sp3. Now if you see CuCl4, okay, let us CuCl4 3 minus, so copper plus 3 oxidation state generally doesn't we get. So we can eliminate this option, we can check with CuCl4 2 minus. Now if you see Cu is in plus 2 oxidation state. So plus 2 oxidation state means its electronic configuration is 3d9, right? Now if I have this 3d9 electronic configuration, we'll have 1, 2, 3, 4, 5, 6, 7, 8 and 9. So what happens here, this 3d and we have 4s and we have 4p, right? So this one electron, okay, this one electron is shifted to this orbital. Okay, now we have this DsP2 orbital are available for hybridization, right? This is the demerits, or you can say the limitations of valence bond theory, which could not be explained, and that is why we need crystal field theory, right? So the electronic configuration or the hybridization for CuCl4 2 minus is DsP2. So the correct answer is your option number D. Okay, next question. The cationic complex is, so you can see here cupro ammonium is there. So cupro ammonium, if you have CuNH3, okay, so we will get a positive or the cationic complex here. So the correct answer for this question is option number A. Cyanide is a negative ligand, and again this one is negative ligand, this one is also a negative ligand. Okay, next question. The complexes CONH3 whole 6, CrCN6 and CrNH3 whole 6, COCN6 are the examples of which type of isomerism. So what has happened, if you see, this has come here and this has come here, right? So these are your coordination isomerism where the metals can exchange. Okay, the correct answer for this question is option number C. Next, which compound is zero valent metal complex? Okay, so here if you see, this is plus 2, so metal charge is plus 2. Here also it is plus 2. Here it is 0, right? The correct answer for this question will be option number C. There is no charge on the complex, so it is a and CO is also a neutral ligand, so the metal will have 0 valency. Correct answer will be option number C. Next, which one of the following ions has an octahedral structure? So if you remember, for coordination number 6, the structure is always octahedral. For coordination number 4, it can be two type, either it is square planar or it is tetrahedral. For square planar, we need DsP2 hybridization, and for tetrahedral, we need sp3 hybridization. So here you can see only one option is having 6 coordination numbers, so the correct answer will be option number D. Next, more salt. So more salt formula is FeSO4 ammonium sulfate dot 6H2O. So correct answer will be option number A. Next, TiH2O whole 6 2 plus is a 3D2 configuration. The value of crystal field stabilization energy is. So if you have this one, crystal field stabilization energy, we will have this type of diagram, okay, and this one is minus 2 by 5 delta O, and this one is plus 3 by 5 delta O, right? Now you have 3D2, so 2 electrons are there, so we will fill this one 2 into minus 2 by 5 delta O, right? So that is minus 4 by 5, or I can write 0.8 delta O. So that is 0.8 decreases by it is given, so that is why minus is not given in the answer. So 0.8, the correct answer will be option number D. Next, among the complexes of nickel listed below, the following is the only correct statement. Okay, yeah, this one I was discussing at that time. The geometry for NiCO4, if you see, the coordination or the oxidation state of nickel is 0, so the configuration will be 3D8 4s2, right? So we get like this, we have 3D8 3 4 5 6 7 8 and we have 4s2. Now what happens, both the electrons shifts here, so it is becomes like this because CO is a, why there is pairing, because CO is a very strong field ligand. So now we have this S and 4p orbitals are available, right? So sp3 orbitals are available. So the hybridization is sp3, so geometry will be tetrahedral. So for nickel carbonyl, the geometry is tetrahedral. NiCN4 we know square planar, NiCl4 we know tetrahedral. So all the metals have all of them have tetrahedral geometry. This is incorrect. 1 and 3 have tetrahedral and 2 is square planar. This is correct. So the correct answer will be option number B. Okay, very simple one. Next, the formula for sodium trioxalato aluminate is. So first of all, trioxalato is there, means there should be 3 trioxalato, but this one is incorrect because it is outside. We can eliminate these two, other 3 options are there. Next is, we have to check the oxidation state of aluminate, right? That should come 3. So let us check for the first option. So sodium is +4, aluminum we will find out, and each C2O4 has -2 oxidation state. So 3 into -2 will be -6, that is 0. So we'll get X is equal to +2. So here aluminium is in +2 oxidation state, but the given value is +3. So this cannot be answer, incorrect. Now if you see this one, the third one, okay. So sodium is 3 plus, each sodium is +1, so 3 sodium will have +3. Then we will have this one as X, and then this one is -6 is equal to 0. So X is equal to +3, which matches the value given in the name, right? So the correct answer for this question will be option number C. Next, which one of the following coordination entity is chiral? Okay, so whenever you have a chelating ligand MAA2 and B2, this type of, if you have any complex, the cis form of that one will be optically active. We all know that, right? So now if you see here, this one is there transform, so this will be inactive. This is not of this form AA2, B2, this is different, so this is also inactive. Now if you see this one, cis form Cl2 oxalate 2, so this comes under this form, so the correct optically active form will be option number C. Next, the complex PtCl2En2 2 plus shows. So this one again, if you see, it is a type of MAA2 B2 type, right? So if this is there, it can show you geometrical isomers cis and trans, and the cis form will show optical isomers also. So it shows both geometrical and optical isomerism. So correct answer will be option number C. Next, the complex is given, you have to find the IUPAC name. Okay. So first one, if you remember, this is your negative complex. For negative complex, the name should end with the Latin name. So argentate should be there. So we can eliminate the first option. Now if we see here, the ligand is amine, so we have diamine silver 1, dicyanoargentate 1. Okay. Here what is the problem? Here the silver is dicyanosilver is written first, so cation should be written first, that is wrong. Here we have diamine silver 1, dicyanoargentate 1. So these both the options are same. So the correct answer can be option number B as well as option number D. Okay. Next, molar conductance of a complex cobalt is 0, then its structure would be. So when conductance or when the conductivity becomes 0, when the anions produced are 0. Now if you see here this complex is having 3 times and chlorine is 3 times. So total 6 ions will be produced. So this will not have molar conductance 0. Here you see this is 1 ion and this is 3 ion, total 4. So this molar conductance will also not be 0. Here if you see this is whole 1 ion and chlorine 1 ion, so total 2. This one is also not 0. But here if you see, this one doesn't produce any ion, right? We know the secondary or the coordination number, the coordination complex will not dissociate when you ionize it, right? So that is why here the molar conductivity will be 0. So correct answer will be option number D. Next question. The crystal split field splitting energy for the high spin D4 octahedral complex is. So if I draw this, just now we had drawn the diagram. This is T2G, okay, and the energy here is -2/5 delta O, and the energy here is plus 3 by 5 delta O. Or I can write this is minus 0.4 and this is plus 0.6. Now if you see D4, 1, 2, 3 and 4. So we will have 3 electrons with minus 0.4. There are 3 electrons and the value is minus 0.4, plus we have 1 electron with 0.6, right? So we will get this one is minus 1.2 plus 0.6. We will get minus 0.6. So the correct answer for this question will be option number B, minus 0.6 delta O. Okay. Next question. In a particular isomer CONH3 whole 4 Cl2, the Cl-CO-Cl bond angle is 90 degree. The isomer is known as. So if it is 90 degree, it is in this form. You can see Cl here, and we can have NH3 here, and we have chlorine here. I'll draw it again. Once again, you check. So if we have this structure, right? NH3, NH3 and NH3 and one more NH3 I'll add here. So this is in one plane, right? And this is the perpendicular to this. So you can imagine this is perpendicular and this is in the plane. So this angle is 90 degree, right? So this is which type of isomer? This is a cis type of isomer. So the correct answer will be option number B. Next, the anion of acetyl acetone forms a COAC-AC whole 3 ring chelate with CO3 plus complex. The rings of the chelate are. So if you know, this COAC-AC3 forms a 6-membered ring, right? So the correct answer for this question is option number C. Next, the correct IUPAC name for the given compound CrF2En2Cl is. Okay. Now if you see here, first of all we need, there is no chloro is outside, so this one will not come in the name, so we can eliminate this one. Next we have difluorido, bis, ethylene diamine, chromium. This part is correct, chloride is correct, only we should check the oxidation state. So if you check here, chromium is X, F is minus 2 and then En is 0 and then chlorine is 0, chlorine is minus 1, so I'll get X is equal to plus 3. Yeah, so this is correct. So the correct answer for this question will be option number B. Okay. So these were the top 30 questions from the one of the most high weightage topic, coordination chemistry. So please solve these 30 questions and just like evaluate yourself how much you have prepared for this topic, and if you have any doubt in any question, please comment it down. We will definitely take it in my next video. Okay. So if you have found this video helpful, if you are liking our efforts for your preparation of COMEDK 2024, please like, share and subscribe our channel. It really motivates us. Thank you, and please prepare well for your exam. All the best.